All right, hello again, Algebra 2 people. So we are beginning a new unit on polynomial functions. And kind of the beginning part of that is just determining some different attributes of graphs of polynomials. So we're going to look at a couple graphs here today, and because these questions are really based on figuring out these different attributes by looking at a graph, right? So, and there are some patterns that can come up, once you talk about, knowing the degree and coefficient, stuff like that, but it's really just identifying these different characteristics from looking at a graph. So I'm gonna leave this up here for just a minute. If you need to pause the video while I'm talking or just take a screenshot, I'm gonna be referring back to this, but I'm not gonna go back and forth just because that'll take. And I'm going to be on two different pages. It'd be easier just to kind of stay on the one that I'm on once I start looking at the graphs. So we're going to talk about the domain and range. That shouldn't be an issue because you've been talking about domain and range for several years of your mathematical career. So that's going to be pretty easy. I will say for polynomial functions, the domain is always going to be all real numbers. So that's the easy part. The range can be different depending on what the degree is of a polynomial. And remember, the degree is just the biggest exponent of x at any given time. If that biggest exponent is odd, 3, 5, 7, 9, whatever, then the range is also going to be all real numbers. But if the degree is even, then it's either going to be negative infinity to a maximum value or a minimum value all the way up to positive infinity. And we'll see a couple of examples like that in just 1 minute. But some of the new attributes we're going to be talking about, the first one's called end behavior. And it's literally just what it sounds like. It's just saying, what does the graph do on the far ends? What happens on the far left? What happens on the far right? The only answers there for end behavior is either going to be infinity or negative infinity. Because if it's going up, going to infinity. If it's going down, going to negative infinity. The notation you're going to see is right here. So it's that LIM that stands for limit. It's actually calculus notation. So if you see the limit as x approaches negative infinity of the function, that's talking about what's going on the left-hand side. If you see the limit as x approaches positive infinity, that's just asking what's happening on the right-hand side. And then the next attribute or characteristic are minimum and maximum values. It's exactly what it sounds like they are. But we do have a couple of different kind of subcategories. We can talk about local or relative min or max values. That's what happens like in a little neighborhood or an area. Or a global or absolute minimum or maximum values. That's where the graph never gets above or below that point. And by the way, the kind of grand term for all of those things together is called extrema or extreme values. And the last thing, once you know your minimum maximum values, then we can talk about increasing and decreasing intervals. And again, it's just what it sounds like. If the graph is increasing, it's rising from left to right. If it's decreasing, it's falling from left to right. And it's going to change, like it'll go from increasing to decreasing at a minimum or maximum value. Okay, so let me bring up a couple graphs, and we're going to look at some graphs to kind of see what this looks like in practice. Okay, so here's my first one. So we're going to do this in kind of the same order that I talked about just on that last screen. So domain and range. Let me actually get rid of this, just the graph a little bigger. So the domain, again, for any polynomial function, the domain is going to be all real numbers, negative 3 to infinity. And for this case, and you can see that the range, that the function goes up and down forever and ever. It goes down on the left and up on the right. So the range is also going to be negative 3 to infinity. Okay? Next thing was that end behavior. And I'll go ahead and change colors when I talk about some different things here. So the end behavior, again, what happens on the left? So in notation, it would say the limit as x approaches negative infinity, that's going to the left, of the function, call it f of x. What happens? As x goes to the left, it goes down, 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 down. So the end behavior is going to be negative infinity. And then off to the right, what happens? That's the limit as x approaches positive infinity of the function. Well, on the right-hand side, it's going up forever. So that end behavior is going to be positive infinity. Don't overthink end behavior. It's literally what happens on the left-hand side of the graph, what happens on the right-hand side of the graph. And your only options are going to be negative infinity or positive infinity. Okay. Next thing, let's talk about the minimum and maximum points. So you can see on this graph pretty clearly, there's a maximum point right here, kind of like at the top of the hill, if you want to kind of imagine it that way. And then there's a minimum point here, kind of at the bottom of the hill, right? Now, we can use Desmos to kind of get the exact values. I don't really care about the exact values. I'm more interested in the concept. The main part here is notice, because the graph keeps on going up, 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 on that other side here, this is a maximum, but it's only a local maximum, because in that little neighborhood, it's definitely the top of the hill, but it's not the highest point ever. It's kind of like thinking of, if you have a little high point somewhere where you live, that's a local maximum, like a little hill in your neighborhood or whatever. But is it the highest point on Earth? No, that's Mount Everest. Okay, so it's a difference between, is it the highest point ever or just the highest point kind of in a little spot? So that'd be a local max, and this guy down here, same deal. This would be a local minimum. Okay, now we can name those points. I'm just going to estimate that at, each line here is 1, so I'm going to estimate that at like 0.2 and like 8.1 or something like that. Doesn't really matter. And the same thing here. This is like 3.1 and -4 or something like that. Again, not too worried about the exact points, but we need the points for the next thing we're going to talk about, which is increasing, decreasing intervals. Okay. By the way, we also talked about there's also this absolute max or absolute minimum. There's none in this case because, again, the graph goes on forever to the top and to the bottom. Okay. And then the last topic was increasing, decreasing intervals. And again, I like doing that last because it's after we have our maximum and minimums kind of labeled. So for our increasing intervals, it's literally like as you're looking at the graph, it's almost like you're reading a book. Is the graph going up in that section, or is it going down in that section? Is it rising or is it falling? And if you see, as we go left to right, in this first section here, the graph is rising as we go left to right. So that's an increasing interval. So and when we write the intervals, we always are going to use the x value. So it's a horizontal measurement, right? So the first increasing interval is going to be from negative infinity, because it's increasing this whole entire time until it gets to that first maximum, so 0.2, we'll call it. And then after the maximum, what happens? Now it starts falling, so it's decreasing from 0.2 until it hits the minimum point at 3.1. And then after the maximum, it starts increasing again, starts rising, and it does that forever and ever. So the other increasing interval will be from 3.1 to infinity. Okay, it's always going to change from one to the other at a minimum or maximum point. Whether it's local or global, it doesn't matter. It's always going to change one to the other. Okay, so those are your attributes: domain range, end behavior, minimum, maximum points, increasing and decreasing. So let me get rid of all these guys, and I will change to a different graph. Kind of let you think about doing one on your own. So here's another one. Similar kind of shape. It's kind of upside down, if you will. So if you want to pause the video real fast and see if you can figure out those same ones. So we get domain range, end behavior, minimum, maximum points, increase and decreasing, and just estimate those points on the minimum, maximum points. So let's go through these real quick. So again, the domain, all of your numbers, no tricks there. The range, also all of your numbers, goes up and down forever. No tricks there. End behavior, the limit as x approaches negative infinity. So again, to the left, what happens as it goes to the left? Well, it's going up. So the end behavior here is going to be positive infinity. And the limit as x approaches positive infinity. So now it's going to the right. What happens on the right side of the graph? Well, it's going down. So that end behavior is negative infinity. Minimum maximums, again, we only have locals because it goes on forever and ever in both directions. So this is a local min, and I'm going to call that -1. I'm going to call it -1, -4, close enough. And then we have a local max, and I'll call that like 1.8 and 8.1. Close enough. And again, there's no global min or global max. We'll see one on the next graph. But there's no global min or max on this one. And then lastly, increasing or decreasing. Again, just start on the left and what happens? Well, my first one, as I go from the left here, it's falling from left to right. So that's a decreasing interval. And again, we're doing the x values. So it decreases the entire way until it gets to -1. And then it starts rising. So it's rising, increasing from -1 to 1.8, we'll call it. And then it starts falling again from 1.8 all the way to infinity. So decreasing 1.8 to infinity. Let's go and look at one more, and one that's going to look a little bit different than the first two we saw here. And we can talk about what a global minimum or global maximum would look like. So here's another one. And you can see this looks kind of strange. This is actually a fourth degree. This is an even degree polynomial. So how would you do this one? So again, start at the beginning. Domain, all real numbers, negative infinity to infinity. It goes on forever and ever. Goes up super fast, but it goes on forever. But notice the range in this point. The range is a little bit different because here, if I go ahead and kind of mark that minimum point here, this point right here would be a global minimum. I'll talk more about that in a second. But if I kind of label that, I'll call it -1.5 and -2.8. Close enough. Well, now my range, it never gets below that point So that means my range is from negative 2.8, remember y values, negative 2.8 all the way to infinity. If it had been upside down, like if it would have been like this, then it would have been from negative infinity to whatever. Okay? How about my end behavior? The limit as x approaches negative infinity. So as it goes off to the left, what's happening? Well, both ends are doing the same thing. They're both going up, right? So as it goes to the left, it's going to positive infinity. As x goes to the right, it's also going to positive infinity. So in this case, both end behaviors are just going up to positive infinity. Minimum, maximum values. Again, I just labeled that first point since when we did our range, but notice that point there, that is a global, or some people call it absolute. It's a global minimum. Technically, it's also a local minimum, but I'm not going to be that picky about it. And then we have a little tiny kind of hump right here, a little hill. So that would be a local max at 0, 0. And then we got this little tiny thing right here, that little valley, that's a local min. And that's the last one I have. But I'm going to call that point, I don't know, how about 0.8 to negative 0.5. And again, there's no global maximum here either. By the way, for the ones you're going to see, you're not going to have, you're not going to have both a global minimum and a global maximum. Not saying it couldn't happen if we kind of restrict things, but for general purposes, if you have a global minimum, you're probably going to have one or the other of the globals. And last but not least, increasing. Again, I'm going to ask that you pause the video real quick, see if you can do your increasing and decreasing intervals on your own. See if you can write those out. And again, we're looking at it from left to right. So what's my first interval? Well, the first thing it does is we go left to right. It's falling, so it's decreasing from negative infinity until negative 1.5. And we're always using the x value. And then it starts increasing for a little bit. So it's increasing from negative 1.5 to 0. And then it decreases for that little tiny bit right there between the maximum and the minimum. So it's decreasing again from 0 just until 0.8, a little tiny bit. And then it starts increasing and does that forever. So it's increasing again from 0.8. Try that again. Increasing from 0.8 all the way to infinity. So those are your attributes of polynomial functions. As always, if you have questions, come into tutoring, talk to your teacher, send me a message. And until next time, stay safe.